Hello and welcome to another video. In today's video, we will be talking about thermal energy transfer and how thermal energy in the form of heat gets transferred between objects. So as a review from way back in Unit 1, we know that thermal energy is the energy of temperature. Many people say that thermal energy is the energy of heat, but more accurately we would say temperature. We know that things with greater thermal energy have higher temperatures or are hotter, and things with lower thermal energy have lower temperatures or are cooler or colder. Thermal energy is transferred from one place or one object to another through heat. So when thermal energy is moving, what we observe is the movement of heat. Now heat always transfers in a very specific direction based on one rule, and that is that heat always moves or is transferred from areas of high temperature to areas of low temperature. So no matter what the situation is, we know that heat, or thermal energy, will travel from where the temperature is higher to the area where the temperature is lower. When we have these two locations with a difference in temperature, one area with higher temperature and another with lower temperature, we call this a temperature gradient. In order for thermal energy to transfer in the form of heat, there needs to be a temperature gradient, or two different locations with different temperatures. Now, we can start to think about why heat moves in this direction. So we know that heat is going to move from where the temperature is very high to where the temperature is very low. And here's the reason for this. We know that what the heat wants to do is reach a state called equilibrium. This means that it wants both of those areas to be equal in temperature. For that reason, heat is going to transfer from that area of high temperature to the area of low temperature until the temperature is equal in both areas, or as close to equal as possible with the amount of thermal energy that's present. Based on this, we know that if there is a greater temperature gradient, meaning there's more difference in the temperature, more thermal energy is going to be able to transfer before that equilibrium is reached. Let's look at an example. So if we think about a nice cup of cold ice water sitting outside on a very, very hot day. Before I tell you, think about it for yourself. Based on what we just learned, in which direction is thermal energy or heat going to travel? Well, of course, we know that heat likes to move from areas of high temperature to areas of low temperature. So what's going to take place here is that thermal energy in the form of heat is going to transfer from the surrounding air, which is at a higher temperature, into the ice water, which is at a much, much lower temperature. Now this is going to happen, a very good amount of thermal energy transfer is going to happen in this instance because there is such a large temperature gradient or such a large difference in the temperature in the two locations. This will continue to happen until equilibrium is reached. This means that the temperature of the ice water eventually reaches an equal temperature or as close to equal as the surrounding air as is possible. So if you leave this nice cup of water outside for long enough, you will eventually find, instead of cold ice water, hot water, because enough thermal energy has transferred into that water to reach a state of equilibrium. Let's look at another or a reversed example of this. So what if I were to take a nice steaming hot cup of coffee and put it outside on a freezing cold snowy day? Think about it for yourself. How would thermal energy in the form of heat transfer in this situation? Well, based on what we've just learned, we know that thermal energy in this case will travel from the area of higher temperature, which is of course the steaming hot coffee, out into the surrounding air. Because we know that heat transfers from areas or objects with higher temperatures to areas with lower temperatures. Just like in the case of the ice water, this thermal energy transfer will continue until equilibrium is reached. So eventually, if I were to go check on my steaming hot cup of coffee, it would no longer be steaming hot. After enough thermal energy transfer has been allowed to happen, I will find that equilibrium has been reached, and the temperature of the coffee is just as cold as the temperature of the surrounding air. So now that we know what thermal energy transfer is and how it occurs, let's talk about the 3 different ways that heat transfer can happen. The first, and probably the most important for you, is conduction. This is the form of heat transfer that occurs through direct physical contact. For example, if you were to take your hand and place it onto a hot pot that is on the stove, heat, or thermal energy, would be transferred from the pot to your hand through that direct physical contact or touch. Convection, probably the second most important, occurs when a fluid, this can be either a liquid or a gas, is heated and then begins to travel away from the source. You can think about what happens inside of this tea kettle when water at the bottom of the kettle is heated and it begins to travel up and around and heat the surrounding fluid around it. Finally, the third form of heat transfer is radiation. This is when heat is transferred through rays, waves, or particles. The most obvious example of this being electromagnetic rays being emitted from the sun and radiating through space all the way down to Earth, transferring heat from the sun to our planet.